Hello, everyone. Welcome to today's Hager webinar. The topic for today is arc fault detection devices, increasing protection. How do we increase the protection using arc fault devices? The topic for today. And my name is Arun, and I'm the Senior Applications Manager for Hager in the Middle East. So I will take you through this presentation in complete details, starting with a little simple approach and then giving you a little more technical information and also touching upon some standards and regulations as well. Before we go in detail, please note that this webinar is actually only on listening mode only, and there will be a question and answers session at the end where you can actually type your questions on the chat box, and I would definitely try my best to answer your questions. So as I said earlier, we have some topics today to cover. Some of them are things which we already some correlation to this topic and drill down a little detail into the working principle of the AFDD and standards and regulations, because some of you might be really interested in knowing the text details of the standards and regulations, how it is evolving and where it stands today. And before I complete, I would show some information about the Hager AFDD solutions, what we have for today. So I think you're all ready to listen, and we start with just knowing what are the causes of electrical faults today. We all know a lot of them actually. So I start from the easier part where we say what electrical faults and what causes and risks we face normally. Of course, we all know there is a overload electrical fault potential which is there. Even in every homes, every offices, we are there. Maybe sockets with various equipment. So we know that this is one potential possibility, and there is a short circuit possibility with line neutral most of the time touching, without our real, awareness. So this creates a short circuit. There are leakage currents, earth leakage, which can give a shock, and sometimes even it can go up to cardiac arrest. We have over voltage sometimes, coming as an input. This can happen if there are not a proper, voltage stabilized input. Lightning, in some countries and sometimes even in countries where lighting is rare, sometimes it may occur and it can have a lot of distraction coming around this lightning effects. One more is this arc, what we are recently hearing about this, electric arc fault. What is this, and how is this topic evolving? And we will see a lot of discussion today on this particular point. So we go into the next slide to just understand how we are protecting all what we said just now using our protective devices. For sure, we all know for over, even for short circuit, MCBs are used. For leakage currents, RCCB, RCBOs are in place. So we have devices already in place for all this what we spoke about, the faults. For example, the over voltage, you can add an over voltage auxiliary or even stabilize it before giving an input. For lightning, there are surge protection devices. So this is you can say a new trend to add these devices into the distribution board to safeguard against lightning. So when we look at all what we saw a little earlier, there are devices in place, and it has already been in stages in IEC, and it's gone from recommendation to should have in most of the projects. But what we are now talking about, this electric arc, in most of the places, even till today, there is no device in the distribution board to safeguard against this. So the topic today would be focused on this, and the solution, for the future would be to, take care of this electric arc fault will be the arc fault detection device. So this is what we would focus on today. So when we said electric arc faults, um, let's ask ourselves, what are the causes? And are arc faults not there today? And why don't we have the devices for all these years, when we have MCB and, our RCCBs, but why don't we have the AFDD in place? So let's understand little by little where it stands and how it can affect. So the causes of electric faults are normally, due to some of the simple things we do normally, thinking nothing will happen. Let's put it this way. For example, we put a plug with a little angle, over a period of time, it can either break or it can have a cut, for example, or due to a lot of usage, we keep moving the cable, so there can be a cut on the insulation. Some examples, to explain where it can cause, things we might do it at home. An electrician coming home does not know exactly where the cables are running in the wall. So while putting a drill, he might, unknowingly damage a little bit of insulation. This can cause arc fault. Sometimes the wire stripping is not done properly. This can, over a period of time, create an arc fault in the circuit. An incorrect bending, bend it and then press it inside the back box, for example, could lead to an arc fault over a period of time. Loose screws could be a reason. A defective wall plug, what we are trying to use, could be a reason for this. Or even, rodent bites, where we don't even know, in the false ceiling there are some rodents and it's doing its biting, and this can cause an electric arc. Look at all this, and if not even more, sometimes we even put some cables on the floor and we keep pressing with our leg, or there is a door which is crushing it. All these are possible causes, simple things which we do at home. We will understand why today it is not a big thing to look at, and why it is being looked at sooner. This is the topic, because most of the are the simple things in our mind that we don't mind doing it. You see that, putting a cable into the wall box with a lot of pressure, we do it, or electricians do that. So how do we then understand a little deeper into this topic? Let's understand what are the types of electric arc faults. There are two main types. One is series arc fault and parallel arc fault. Understand, because in our electrical world, when there is a line and a neutral running, there can be a rupture within the line itself, and this can cause a series arc fault. But when we look at parallel arc faults, it's between the lines, either a line and a line in a three phase, or a line and a neutral in a single phase. There can be an arc fault, happening, which we will, it can be destructive. Then it can also be a line and an earth. So this is also possible. You will also see in these two cases, line and a neutral, we always know when it happens, it becomes a short circuit. But we are here talking about arc fault. So the difference here is its magnitude. The short circuit is really a direct contact with that, and the short circuit current goes up to, we know that, amps or 10,000 amps. But here we are talking about a line and a neutral. It's standing close to each other with a little rupture in the insulation. This arc creates a smaller amount of current transfer, but quite high than its rating current. Let's say, like, maybe instead of 6,000 amps, it will go to 70 amps, 100 amps. But our MCB is 10 amps. But here this will happen. But this will happen in a different curve that the MCBs cannot detect this. So this is where, what has happened. Neither our MCB nor our RCCB can detect these kind of arc faults which are happening today. And its waveform, its magnitude are completely different from the curves we have it for MCBs. So this is an important understanding we should have. What could be the working principle for AFDD? So before seeing actual AFDD working principle, I would actually try to touch upon some working principle of the existing other devices, which we already know, but just to show how different is the working principle of AFDD, or how you can even sometimes say how complex is the working principle of AFDD, which is going to be. You will see. For overload, it works on bimetallic strip. So thermal magnetic, the thermal part will work on this bimetal. Short circuit, we have the electromagnetic induction, the magnetic coil, which actually is the principle used for the working of this device. The leakage current, there is a RC core and a relay, which is inside mainly, which does its job. And amount of physics is there, but it is one or two parts, which is the heart of the whole product. Of course, in a voltage, we need to do a measurement, how much it's coming, and then take an action or to trip it. Lightning arrestor, there is a spark gap technology, which I think in the last webinar you might have heard about this. This is the technology being used. But when it comes to the curves are different from MCB. The magnitude of currents coming through it is very different from the short circuit. So it's neither classified in any of the other ones, but we still have to be careful about this kind of a fault on a long term. So what all it does, I just put it in simple things, but not in full details. We will see it in the next slide. For example, the RMS value of the arc would be calculated, in some value, and the duration of the arc is being monitored. Unlike, it should not be the overload, it should not be the short circuit, but it is in between. But then what is its curve of time, for example? So irregularity of the arc, because arc can happen sometime there can be a blank, that can happen again, carbon deposits happen. So all this is being considered in this. There is a high frequency disturbance sometimes, when the arc is little in a bigger cable, we can actually hear the sound, but within the homes and offices, we can't hear the sound, but there is an arc and a very little hissing sound as well, which can be generated. So there is a frequency coming up. A specific arc waveform is monitored, by this device. So you see, first of all, it is not a simple device that just does a bimetal activity or a magnetic coil or to take a lot of information and monitor it over a period of time, because this arc fault is not dangerous on day one or at the first instance. It needs to be monitored, and it might not all the time result in a fire. So a lot of permutation combinations of these data is done to identify if this is going to be a dangerous arc. So in reality, what happens, there is an using a microcontroller which is inside this, which does this. So there is a lot of sensor, lot of data analysis, and this data analysis will be finally taken out as an action to either trip it or not to trip it as a final outcome. So in a broad spectrum, if you look at it, AFDD is a little, you can say, complicated or intelligent device, looking at a lot of parameters. The embedded data processing happens inside. Let's take it a little further. Okay, you don't need to memorize any of these, but just to know how detailed it could go, like we said, some values of these are the ones which are given in the IEC as well to monitor. These values should be taken into consideration into the working principle. The same one, what we saw earlier, I'm just exploding it a bit to show you how much it can go, of the arc is being calculated in these formulae and these curves. The normal curve is this way, and the right side you can see is a little abnormal. All this are being calculated and monitored over a period of time. So high frequencies, this can happen with a disturbance, and this is monitored internally. And whenever this happens, immediately it will not take an action, but it will monitor to put all the data together to take an action. That's the beauty of this product. Arc waveforms, there can be a sudden change. You can see a step in the picture. It can happen like this. Then this will pick up this information and store it in and start analyzing that. And with all this, if there is enough data or a proof for the AFDD that this is going to be a dangerous arc soon, then it will trip. This is the idea of this whole product. Embedded data processing, what I said in a block diagram. See, electrical values, analog measurement chain happens, electronic signals, converted into digital values, then doing some internal digital computing, secondary parameters, microcontroller. So you see, whatever I said, is all there summarized to give you an idea. It's not just one MCB curve. This is a lot of data, lot conversion, computing, and then a decision is taken with the trip command to actually have an electromechanical actuator to trip it. So this is a summary of this working principle using the microcontroller, which is inside the AFDD. So from a simple approach, we now came to the working principle to understand that AFDD is an intelligent product, you can call it, with a lot of electronics mixed in, and then a microcontroller processes it to take a final decision out of it. I wanted to add some good information about IEC because a lot of us are in technical world, and we need to understand why MCB is today, a compulsory product inside a DB, and why not default device is a compulsory product in the DB. It all starts and ends with IEC. So let's understand how IEC standard and its regulations are today and how it is expected to evolve as we move on. This could be informative for some technical people, and I collected some good amount of information on this to show you all. Let's start with this IEC 60364. Okay, this is edition 3.1 and 2014. And this one is a installation standard which talks about recommended use of this product. Okay, so in 2014 itself, the discussion started on this IEC 60364 installation standard, but it did not mandate it. Okay, so this is one very important point to understand why it is still not in use unless it is mandated. Like, for example, even RCCBs have been mandated, in many countries. So it needs to be mandated for a compulsory use. But today, let's say the risk of this dangerous arc is not fully pronounced, and the people have analyzed it to understand it is also a risk we need to work upon. So 2014 recommendation says in sleeping accommodation, like hostels, hotel, bedroom, we need to use this as a circuit protection. Maybe in some place where there is a fire risk happening, it needs to be used. I just go through it a little faster, but then try to understand edition 3.1 did a recommendation and it did not do a mandate or a mandatory thing. This is the main point from this one. So all these places where to be used were good, like museums, libraries. Once there is fire, you can never replace them. It's so important. Like congested buildings or high rise, if a fire happens, the damage could be very high. A lot of people could die because you cannot run from top to the 20th floor or a 40th floor to come down before. So all these were well documented, but it was just a recommendation till then. While it was recommended on the installation standard, always when an installation standard starts recommending, a product standard gets evolved. So a product standard for arc fault detection device is actually IEC 62606. So this is a product standard coming from an installation standard recommendation. So once it is recommended, some people might start using. So what product to use? AFDD. So what is its product standard? It is IEC 62606. So this is already evolved. So product standard is already in place. Only the installation standard, which has been published already, 3.1, just recommends it. Now let's go a little further. Okay, the same standard, installation standard, IEC 60364, but edition 4. So edition 4, they started discussing from 2019, after 2014, the edition 3.1 was released. This discussion came up to mandate AFDDs, which is a very good thing, but this is a discussion which started. But if you look at it, we are expecting probably a publication in 2023. Okay, so we are in 2022, and we understand this discussion is in the last stages. So either early or mid 2023, this is expected to be published with the mandatory requirement along with the RCDs. There will be a shall be provided. Shall be provided means it is mandatory from the recommended to be used, in the previous edition 3.1. So this is a good thing to understand. Little by little, we are going into more and more protection at home. Even today, we are living without this product. And, touch wood, there are not many fires, but then there are fires for various reasons. Some could have been, an arc fault. So this will be slowly in place as a product, AFDD, in every home and offices or whichever circuits which the IEC is recommending. Then this will reduce. As I said, the product standard is already in place, IEC 62606 AFDD. So the only thing is the edition 4 mandate is awaited. And in this, some locations have been little modified, but it's okay. They have actually not mandated for every place. They only said if there is a place for intended for sleep, it has to be used. It's occupied by a group of persons, we need to use it. Inflammable places, irreplaceable goods, wherever it is there, it should be used. Agricultural livestock are kept. These kind of places and circuits needs to be mandatorily used with AFDD. This is what is this edition 4. But the only thing is, as I said, it is not published yet. It's expecting soon, probably in 2023, because from what we understand, it is in the last stages. So this is something very important to understand as an installation standard and the product standard and where it stands today. That's why none of our buildings anywhere here is already not mandatorily using an AFDD. Okay, so this is the background. But we just saw about the super IEC level. What we have to also see is the regional standards and regulations. I'm just taking some few examples. Of course, we all know in the Middle East, it is not implemented in the regional. So I cannot have a slide to say anything. But if you understand to look at Germany, for example, when the 2014 IEC was introduced, on that time itself, Germany said AFDD is mandatory at all these applications. So they immediately followed the installation standard of recommended IEC standard into a mandatory one in Germany. So from 2014, in all those places which was mentioned, it is already mandatory. They are already using it in Germany. But when it came to October, 2019, they did a small difference. What they said, this arc fault and things are not happening. Only from an electrical point of view, the solution cannot come. So the electric solutions can come from 3 angles. So they expanded it further. They said to avoid it, we need to take 3 measures. Either this or and you can see structural measures can be taken, organizational measures can be taken, or technical measures. The technical measures are the ones where AFDD comes into picture. But Germany went one step ahead. Let's say, it can also have a structural change or structural effort to maybe a thick pipe can be put, for example, so that a rodent cannot bite. I'm giving an example like that. So that's a structural change inside. So this is a very good effort from Germany, and they are already using AFDD in their markets. Okay, so when we look at France, another big country, it's on the other opposite. They do not refer to the AFDDs at all, even till today. Okay, so this is not a good sign, but every country has its right to do depending on where they stand in the electrical progress today. So there is no mandate, no recommendation from the NFC, which is the French local regulation, unlike the VDE from Germany, which we saw was mandatory. So we can see actually 2 extremes. So people are expecting around 2025 at least this might be made mandatory in France. Okay, so this is an information. The last, but a very relevant one, because in our market, normally we have a lot of influence from the BS. So if you look at in the 2014, when it was announced by the IEC, BS decided to implement it as a recommendation from June 2018, and they had it as BS 7671. Okay, this is exactly the equivalent of the installation standard, but they all have their local, let's call it, regulatory terminologies. Like we have VDE for Germany, then we have NFC for France. We always know that there is the BS for the British markets. So here what it says, then they also took it to one more level now to make it a mandate in 2020. The discussion started. And the big news is they already published this new mandate document in March 22, which is this year 22. But the only thing is they have not implemented it, which means they will put a deadline to people to start following, old ones to be replaced. That didn't still happen. But the good step is they already have a local regulation which is mandated the AFDD with an amendment 2. So you can see here amendment 2, which says shall be provided. So from a recommended, which was there in 2018, it's now become shall be provided in the high risk buildings, purpose built student accommodation, multiple occupation houses. Then there is a care homes, for example. So this is where the UK has decided to implement AFDD. And the good news is it is expected to be implemented soon. The publication is done, which means the document is in place. It's already published. Only thing, a strict implementation or a time-bound implementation will soon come up. What it means here, normally Middle East takes a lot of inputs from IEC and the BS. So if the IEC mandates it from 2023, for example, and if the UK has already mandated it from March 2022 in their installation standards, it will soon become a need and then probably even a mandatory requirement within Middle East. So we do not know today. It can have an evolution. So this is the point I wanted to say about the IEC standards and regulations and the regional standards and regulations. Then we will soon probably have some local regulations for us coming up. So as we come a little closer, I wanted to actually say, what do we have as a solution from Hager? Okay, this could also be something you might be wondering. What is there? We talked about AFDD, and is there already a solution in place, or is it still an evolving topic? Like I said, in Germany, it is already implemented from 2014. So the product is not an imaginary product. Hager and the market actually has AFDD, which is a solution. But what we need to look at is for the different needs, the AFDD solution will change, because this is how I understood it. Because let's even say Middle East. What we have here in the final distribution board, some of the markets have DIN rail boards. Let's say Dubai has a DIN rail board where we have isolator, incomer, then RCCB and MCBs there. For example, there are some consumer units, the single phase board, where there is an incomer and then single MCBs on a single row, for example. This is another application, let's call it. Then when we look at the TPN boards, some of the markets have only MCB on it. Maybe let's take an example of Abu Dhabi. We have incomer, isolator, and RCCB outgoing as MCBs. The picture shows it. But this is one construction. But there are some countries, for example, Qatar, let's say, they have a TPN board solution, but they have isolator incomer and MCB and RCBO outgoing. Okay. So unlike other countries where they have one country approach, UK has one way, method of following, Germany has one method, France, but Middle East is a collection of many countries. So we need to understand how to give a solution for each country, let's say, or each different need. So for this DIN rail and consumer units, what will be the solution would be an MCB with AFDD solution, which means, okay, if there is already an RCCB, then we have an MCB outgoing. Each circuit which needs to be safeguarded. Okay, for example, a circuit is going to a bedroom. Okay, because I easily said where some people are sleeping, it's good to put AFDD. Then that MCB will be replaced by this MCB plus AFDD. So this is the point. Okay, so each circuit which needs to be safeguarded will be replaced. The MCB will be replaced by a MCB plus AFDD. In some places where RCDs are not used today, RCCBs, they only have isolator and MCBs, which is not prevalent in Middle East. Then they can directly use an RCBO with AFDD, or if there is a market where they are using RCBO instead of an RCCB, then they can use this solution RCBO plus AFDD. So this comes as a solution for the DIN rail boards and the consumer units. When you look at taking the same product and putting it on TPN boards, it doesn't work, because you can see as an outgoing MCBs have, you need to actually have its construction where it cannot allow a two pole like, MCB and AFDD or RCBO plus AFDD to be put together. This construction doesn't work. So we have a separate product where this MCB outgoing will be replaced with an MCB plus AFDD in a different structure, which is a little taller than the MCB as today. So an MCB will be replaced with this product, but it needs a little space on the board, to accommodate this additional. It's like our one mod RCBO today. The construction looks like that, but it will be an MCB plus AFDD, which can be fitted. So the construction still will remain same, just replace this. Then that particular circuit is safeguarded by AFDD. So let's say, for example, in Qatar, they want for an RCBO. What do we do? So you replace an RCBO with an RCBO with an AFDD in the same size, like a one module RCBO. So this kind of a solution needs to be understood, and we need to try and fit different needs with different products to take it forward. This is the broad idea. I'm not going in details about what ratings we have, what references and things, but this itself would have given you a good idea about where you are in the Middle East and what kind of need will be addressed by which product of Hager. So this kind of an understanding is coming from this slide. So coming to almost the end, what I would actually say is a summary where today we do not have a device being used in our DB to address this arc fault will sooner or later become a mandatory requirement. So when it becomes a mandatory requirement, there could be an example of a final circuit which looks like this. Some of the bedrooms might have an RCBO with AFDD. This I have not put it in the RCBO single mod style, but this is just a picture to explain where some of them might not be using that AFDD. Some circuits might be using AFDD. That's the idea, to show this. So it's not an exact example, but just to give an idea about how this can evolve in our region. So this means we need to have some boards which might need some additional space. This has to be planned in advance, so that a DIN rail board has to have maybe an additional row or maybe an additional module space. So this needs to be planned. So what we mean now is, the need for AFDD to increase the protection is coming more and more in many countries. And we saw Germany is already compulsory. Some other European countries are becoming compulsory. France might do it in 2025. UK is already announced in March 2022 in their installation publication that it is mandatory. So when we look at it, the world was only having an MCB, RCD, and SPD earlier. So we will also plug in this AFDD in the final distribution boards to have more and more protection. So it's not about 100% protection, but what we mean is we try and plug in wherever there are risks, more and more being protected, which is less risk, more and more less risk, because RCDs, in earlier times were never used. People said, Why require an earth leakage to be safeguarded? But today it is a mandatory requirement. We are saving people from little shocks to cardiac arrest because of the RCDs. So, like this, AFDD will become a mandatory requirement soon, and you will see this arc fault protection coming up. And what I wanted to, inform clearly is we have not launched this product in the Middle East yet from Hager, but we would like to probably work with some of our partners who are interested to work with us on pilot projects, let's say. So if you're interested, kindly contact your corresponding sales team, so that we can maybe try and work with you on one pilot project. So this can be an action we can do after this session. So thank you so much for listening, and now it is question time. So if you have some questions on the chat box, let me have a look at it, and I'll try my best to answer you. Yeah. Okay. I see a question from Habib. It says, how AFDD calculate loose plug in socket arcing? What level of arc AFDD tripped and cascading can be managed with AFDDs and the socket? See, like I said, this calculation is not a simple thing. I even put in this presentation only two slides to show you the complexity. The actual presentation has some 20-30 slides explaining different curves, how from the loose plug, if there is an arc coming, or there is a frequency generated, or a different waveform coming up, this is all completely electronic. We cannot explain this, but that is the product. So that's the beauty of this product. So a lot of research, lot of testing, lot of let's call data gathering has happened to create a product like this. So you cannot directly say, if a mouse bites something, how do we calculate? It doesn't go that way. Yes, by doing that, there are various disturbances in the arc form. There is a frequency, probably disturbance. All this are put together in the microcontroller to get an answer. So if the answer comes as, yes, it is reaching now a dangerous arc situation, it will trip. Otherwise, it will become a nuisance tripping also. So it needs to really be, let's call it, a bit more intelligent before it takes an action. So that's how I would try to answer that question. We have, is there another question? Okay, we have another question where it says, if we are using AFDD for final circuit, do we really need to use RCCB as incomer? Yes, yes. Let's say, for example, in a in a DR board, okay, where in Dubai we are using a isolator, RCCB, and outgoing as MCBs. We use, instead of the MCBs, an AFDD variant called MCB variant, that particular one. So when you use that, you are having an isolator. Yes, there is an RCCB, which is also mandatory in the IEC installation standard. Yes. In addition to that, only we are replacing the MCB by a MCB plus AFDD. Instead of one module, it becomes two module. That's the only thing need to be done. And then the whole thing is finished. So, and also it need not be installed in all the outgoing circuits. It can be selective, like we said, where people are sleeping, because there is no time to react, maybe for such kind of electrical faults happening in that room. So that is given first a priority in the IEC installation manual. So that's how, this will work. I think I answered reasonably. Then I have okay, I have a question from Ibrahim, which says, I will mark it as a question so you can see it. AFDD plus RCBO price comparing to RCBO and MCBs. As I said in the last slide, we haven't still launched this product here, which means we have not done exactly a pricing, on all these products for the Middle East. But having said that, AFDD plus RCBO comparing to RCBO and MCB, uh, the, the question is not fully okay because the AFDD plus RCBO will replace RCBO. MCB plus RCBO will replace a MCB. So in that case, of course, AFDD plus RCBO will be expensive than RCBO. But there is no comparison of RCBO plus AFDD to RCBO plus MCB because there is no RCBO and MCB put in the same circuit, because RCBO does the MCB characteristics in addition to the leakage. So, for example, in Qatar, they use for the lighting circuits only MCB. For other inductive circuits where they want to actually put a RCBO, only their RCBOs are put. So there is no mix. I didn't get it fully, but probably I try to answer it like this: RCBO is replaced by RCBO plus AFDD. MCB is replaced by MCB plus AFDD. So the prices will be higher than today, but we do not have yet the pricing because we have not launched yet. And okay, I have a question again from Habib. AFDD can malfunction on harmonics THDV in systems. Yeah. See, so this is how this this microcontroller will isolate and find out if it is really just a harmonic, or is it a frequency curve and an aberration which is going to relate to a dangerous curve. So all these questions are actually answered by the R&D and the product is in place. Let's say like that, because it will not identify another electronic harmonic to be an arc fault, for example. To be straight, if I have to tell you that answer, it will not do that. That is the intelligence of the product. Otherwise, every 2 minutes, this product will trip because there will be a harmonic, there will be an EMC, there could be many things happening at home. So it cannot enter into a complete false triggering. So an intelligence is built in the microcontroller, which will separate all this and say, yeah, these are normal harmonics. I don't need to do anything. Oh, yes, this waveform is pertaining to an arc fault. So I need to look at it. So this is how it will separate it. Yeah. So I have another question from Habib. Habib is quite active today. Thank you, Habib. AFDD can work where not proper waves, like we see ELCB has different type as DC AC circuit. I didn't understand this proper weaves, but AFDD can work. Okay, let me tell you today AFDD can work only on the AC circuit. Okay, and that itself is struggling for an installation standard. So IEC is mainly working on the AC, so no solutions on DC, and still even no solutions mainly for 60 hertz, for example, for countries like Saudi, because the waveforms, the patterns, the disturbances are completely different in each circuit. So your question is valid, and I would say the solutions today are for the standard requirements of the AC, network, electrical network, and at 50 hertz. And that too, IEC stipulates certain ratings only, up to 25 amps only. So IEC says that, the outgoing circuit up to 25 amp alone needs to be safeguarded. And if it is going to bedroom, if it's going to a library, so all those are the mandates they have put. So no solution for the DC yet. Yeah. Okay. I tried to answer some of the questions. Yes, thank you for participating well. And if there are no more questions, I would move to asking a quick question on what we actually saw today as a presentation. So there will be a poll coming up, and if you can answer, you will be answer it will be part of the selection committee to select you as the winner, which we will announce, I think, tomorrow. So kindly go ahead with giving answers. And if you followed my presentation, it should be a quick answer. I'll give maybe a minute or 30 seconds to finish. And if you all answered it correctly, I'll definitely be very happy that you all followed and the message we are trying to convey in the market is going through. Another few more seconds, maybe. Okay, the poll will continue. It will not till the whole session is closed. So you can take few more seconds. In the meantime, if you can give me your kind feedback about how my presentation was and what were the contents and was it reasonably selected for what you were expecting and was it delivered well? All those in your hands. You can give your answers there. Thank you so much for your feedback. Actually, after that. Okay. Um, I think we received your feedback. Thanks for your feedback. Let's keep in touch through our website, hagar-me.com. These product categories are still not in the website, but for all other product categories, you can have a look at there. And kindly follow us on LinkedIn and Instagram. And for a recording of today's session, you can actually view it on YouTube in this link, youtube.com/c/Hagar Middle East. This webinar recording or previous ones, all those will be there for you to relook at it. I hope this session was interesting for all of you. Have a nice day. Thank you so much for your attention. Bye-bye.